Okay, hello, this is David Schwartz. I am your 1440 instructor, and I'm just going to go over a few problems for the first day. The lesson plan is just going to be review covering integrals, which was the last part of Math 1430. So again, my name is David Schwartz, and I'll be your teacher for the next 4 months or so, till the end of the semester. And just remember, go to WebAssign for homework and quizzes. And also WebAssign has great videos for most of these sections that we'll be going over. So between their videos on WebAssign and my videos together, that will be a good start for understanding the material and doing well for the class. Okay, so let me get to work. Okay, so this is the lesson plan. It's actually an old exam from Math 1430, otherwise known as Math 180. And I'm just going to go over a few of these problems. You know, the first one is just a basic integral of a polynomial. And as you recall, you just integrate term by term and use the power rule for integration, and then you add the constant of integration, the plus c, and then you always want to simplify your answer. So you're going to see these exact problems when you go to learn, because these are my notes for our first day. The lesson plan is just going over these integral problems. So you'll see this exactly on Learn when you go to instructor course information on Learn. No, I'm sorry, when you go to the announcements/more announcements, which is on Learn under the dashboard section. Maybe you'll see it right away when you get on Learn. If not, just go to dashboard for the notes. Otherwise, pretty much everything else is in instructor course information. Okay, so first day of class, we're just reviewing 6.1 through 6.5, which is just these integrals. So for the second problem, notice, again, you have an integral of a bunch of terms. So the first step before you integrate is to simplify this expression, this integrand, so that way it's more integrable, more friendly to integrate. So instead of writing 4 over x, because there's no quotient rule for integration, rewrite it as 4x to the negative 1. And then instead of the cube root of x on the bottom, cube root means 1/3 power, but when you put it upstairs, it's x to the negative 1/3 power. Now this is more friendly to integrate. So in this equivalent question, we're ready to integrate. And again, just integrate term by term. I showed all my steps for this example. I just integrated each term. But you could have just gone directly to this step if you wanted to. So you're allowed to pull out constant factors on the other side of the integral. So the 4 I pulled out on the other side, and the 5 I pulled out. So that's a rule of integration. You're allowed to do that. And then the integral of 1 dx or dx is just x. And the integral of x to the negative 1 or 1 over x equivalently is the natural log of x. As a check, isn't the derivative of the natural log of x back to the 1 over x or x to the negative 1? Hell yeah. Okay, and here's the power rule. You increase the power by 1 and then divide by that number. So that's the power rule for integration. So when I increase negative 2 by 1, I get negative 1 over negative 1. So 5x is negative 1 over negative 1. Plus, and then again, the power rule. What's negative 1/3 plus 1? It's a positive 2/3. And then over 2/3. And then finally write the plus c, because this is an indefinite integral. And then you don't want to leave this as your final answer. It's nice to simplify. I mean, certainly you want to, isn't dividing by 2/3 the same thing as multiplying by the reciprocal, 3/2? So that's where the 3/2 comes here. And again, if you look at Learn, you'll see these problems exactly as I have them here. And then it's always good to box your final answers. So there's my final answer boxed. And x to the 2/3 you could just as easily write as the cube root of x squared. Remember, the denominator is the root. The numerator is the power. Okay, well, so let me just quickly look at the next few problems. Generally, I like to make my YouTube videos no more than 10 minutes because I know it gets tiresome after a while to hear me blabber. Okay, Yeah, here's another integral problem, number 3 here. So we don't like radicals with integrals, so rewrite 2x with the square root as 2x to the 1/2 power, because doesn't square root mean 1/2 power? Let's see, this thing isn't focusing right. Sorry about that. Okay, there it is. And then by a rule of exponents, whenever you have something raised to a power, each factor gets raised to that power. So rewrite it as 2 raised to the 1/2 power times x to the 1/2 power dx. 2 to the 1/2 is just a constant, so you can pull that outside and multiply it with the 3. And 2 to the 1/2 is the same thing as the square root of 2. And then finally, we can integrate x to the 1/2 dx by the power rule. Add 1 to the exponent and then divide by the number. What's 1 plus a half? 1/2, which is 3/2. 1/2 is the same thing as 3/2, which looks better as 3/2, over 3/2 plus c. And then just clean this up a little bit. Dividing by 3/2 means multiplying by 2/3. When I multiply by 2/3, the 3 on the bottom cancels with this 3 over here. So that's why I just have the 2 root 2 times x to the 3/2 plus c. Or you could write it like this: x to the 3/2 is the square root of x cubed. So either answer is fine. Now, probably this one's a little preferred because if the question has radicals, it's nice to have the answer returned to radical form. So for this example, I would write it like this: keep the radical form. Because sometimes WebAssign is a little picky with the answers. So, if your original question uses exponents, then have your answer using exponents. If the original question has radicals, then use radicals for your final answer. And the homework, because it's sometimes a little picky, nothing too bad, you're going to get 5 attempts for each homework problem. So if you get the wrong answer, you'll get feedback on what you did wrong, and you can try it again. And you get 5 chances for every homework problem. And you get 2 chances for the quiz problems, but they don't give you feedback on the quizzes. So if you get a quiz problem wrong, you get another chance. And then on the test, when that comes around, you're allowed 2 chances for the test. But really, think of it as just 1 chance for the test. It's only if you make a stupid mistake when you type it in and you realize, oh shoot, I didn't mean to write that. So that's the purpose of the second chance, just to clean up any obvious errors. But for the most part, you really don't get, there's no feedback or anything like that. So when you take the test, if you think you're right, just move on. Don't worry about that second chance for the test or final. Okay. Here's the next problem. Remember, this is a quotient, but there is no quotient rule for integration. We have quotient rules for derivatives, but we do not have quotient or product rules for integrals. So when you see a quotient, very often we do a u substitution. So let u equal the ln of 2x, because isn't the derivative of the ln of 2x 1 over 2x? 1 over 2x, and then by the chain rule times 2. Because you go 1 over the argument times the derivative of the argument. That's how you take a derivative of a log function. It's 1 over the argument, 1 over 2x, times the derivative of 2x is 2, and 1 over 2x times 2 simplifies to the 1 over x. Okay, and then you can, and then from there, there's so many different ways people do these substitutions. The way I do it is I solve for dx, but most people don't do it that way. So whatever way you're comfortable doing. So try this one on your own and see if you can ultimately get this answer right here. This is the final answer. You need the parentheses around ln of 2x. It's the whole thing to the 4th power. Without the parentheses, it's wrong, because that would only be x to the 4th without the parentheses. Okay, so you can see these problems on Learn. And, these I have on Learn as well. So let me just finish, because we're already up to 9 minutes. Let me just do 2 questions now live that are not on Learn. So 1 second. Okay. So number 9 is not on Learn, because I wanted to do this one on YouTube. So let me write number 9 down. Number 9, we got the integral from 0 to 1, x to the 4th plus x cubed plus x squared dx. So there is our problem. By the way, I'm going to improve these YouTube videos. I did buy an easel, so eventually I'm going to use that easel so this will turn out better, these YouTube videos. All right, so to integrate this, notice this is now a definite integral. So we're going to get a number answer for our final answer. No plus c's for definite integrals. So whenever you're given a definite integral, the first step is just to find the indefinite integral. So let's integrate term by term. By the power rule, the integral of x to the fourth is x to the fifth over 5 plus x to the fourth over 4. I added 1 to the exponent and then divide by that number, plus, what's the integral of x squared? Well, I'll use the power rule for integration. Add 1 to the exponent to get x to the third over 3. So there's my indefinite integral, but because this is a definite integral, don't write plus c. Instead, we draw this evaluation bar. We're going to evaluate this expression from x equals 0 to 1. So let's write 0 to 1. Okay, I'm going to draw some equal signs here. Equals, equals. So you input the upper limit first. So when x is 1, what is 1 to any power? The answer is 1. So this first term just becomes 1 over 5, or 1/5. Plus, when x is 1, x to the fourth is still 1. 1/4 we get. Plus, and then 1/3, minus the expression, and now we input the lower limit, 0. So 0 to any power is 0. Isn't 0 to the fifth 0? And isn't 0 divided by 5 still 0? So I'm just going to write 0 plus, and this is going to be 0 plus, and 0 cubed is 0, divided by 3 is still 0. You don't have to write all these zeros. You could just write minus 0. Okay, and then from here, I would get a common denominator. So really, the answer is just going to be whatever a fifth plus a fourth plus a third is. So what's the LCD, least common denominator? I always like looking at the biggest denominator. Do 4 and 3 go into 5 evenly? No. So then 5 times 2 is 10. Does 4 go into 10? No. So keep going. 5 times 3 is 15. The 3 goes into the 15, but 4 doesn't. So keep going. 5 times 4 is 20. 4 goes into 20 5 times, but 3 doesn't, so we got to keep going. 5 times 5 is 25, that doesn't work. 5 times 6 is 30, that doesn't work because 4 does not go into 30. 5 times 7 is 35, 5 times 8 is 40, 5 times 9 is 45, 5 times 10 is 50. So far, they both don't go in. And then 5 times 11 is 55, that doesn't work. But 5 times 12 is 60, so 60 is going to be my least common denominator. So I'm just going to draw a fractional bar with 60 on the bottom. Now we got to change all the top numbers, the numerators, accordingly. Since 5 times 12 is 60, we got to multiply the 1 by 12 to get 12 plus, let me make that neater, 12 plus 4 times 15 is 60. So 1 times 15 is 15 plus 3 times 20 is 60. So multiply the 1 by 20 to get 20. And then that's going to equal, let's see, 12 plus 15 is 27. And then we get 47 over 60. And that's our final answer. Notice that's a number answer as we expected. So 40 over 60. And I'll box that. Done. Okay. And then the last question real fast is right here. Sketch and find the area given by this definite integral. So here again, change that square root to x to the 1/2. So I'm going to just do this one by showing you what I did. So rewrite it as the definite integral from 9 to 25 of x to the 1/2 dx. So to evaluate this definite integral, first step is just to do the indefinite integral. What is the integral of x to the 1/2? It's x to the 3/2 times 2/3. Previously I showed every step, but so really this is really x to the 3/2, x to the 3/2 over 3/2. But isn't over 3/2 the same thing as multiplying by the reciprocal? So 2/3 x to the 3/2, that's the quick way of doing it. And then you input the 25 first, the upper limit. What's 25 to the 1/2 power? That's the same thing as saying what's the square root of 25? That would be 5. So I'm going to get 2/3 times the expression 25 to the 3/2 minus 9 to the 3/2. And that's going to equal 2/3 times, and like we said, 25 to the 3/2. You do the square root first. Do the root on the bottom first. So when the root is 2, that means square root. What's the square root of 25? 5. And then that gets raised to the power of the numerator, 3. So 5 cubed minus, and then the square root of 9 is 3. So it's going to be minus 3 cubed because the numerator is 3. That's the power. And then you got to simplify. What's 5 cubed? It's 125. What's 3 cubed? It's 27. And then 125 minus 27 is 98. So 2/3 times 98 over 1 is 196 over 3, which is a big number. You can just leave it as an improper fraction. So that would be the area. And then since it says to sketch it, here's the graph. This is the graph of y equals the square root of x. From x equals 9 to 25, because those are our bounds, the area would be given by those in between those vertical lines, x equals 9 to x equals 25. There's the shaded region R. How many square units is this region R? 196 over 3. Done! Done! Okay, so that's it for day 1. Ciao!